Good morning, sir. Myself N. Devi. I am from ECE. My roll number is 234C 180432. And today my topic is numerical problem on lag lead compensator. First, we can go through the question. Design a lag lead compensator for a given system with open loop transfer function g of s is equals to k by s into s plus 0.5 to satisfy the following specifications. First one is damping ratio of dominant closed loop poles zeta is equals to 0.5. Second one is undamped natural frequency of dominant closed loop poles omega n is equals to 5 radians per second. Third one is velocity error constant kb is equals to 80 second inverse. Next we can go through the solution with step by step process. Step 1. Determine dominant pole SD. Dominant pole SD is equals to minus zeta omega n plus or minus j omega n square root of 1 minus zeta square. In the question they given that zeta is equals to 0.5 and omega n is equals to 5 radians per second. Substituting these values in dominant pole formula, we can get minus 2.5 plus or minus j 4.3. And step 2 is draw the pole 0 plot. The pole 0 plot of the open loop transfer function is shown below in the graph. Poles are indicated by the symbol x and the poles at the point P is dominant pole. Here the graph is indicates the weight 0 origin and the minus 0.5 are the poles and is P indicates the dominant pole. Next we can go through the step 3 to find the angle to be contributed by the lead network, where phi is the angle. The formula for the angle phi is sum of angles contributed by poles of the uncompensated system minus sum of angles contributed by 0 of the uncompensated system plus or minus in 180 degrees. From the graph we know that theta 1 is equals to 120 degrees and theta 2 is equals to 115 degrees. Sum of angles contributed by the poles of uncompensated system is theta 1 plus theta 2 is equals to 235 degrees. Since there is no finite zero in uncompensated system, there is no angle contribution by the zeros. So it is 0. Phi is equals to 235 degrees plus n 180 degrees, where n is equals to 1. Then the angle is 55 degrees. Next, here we see in the graph drawing the theta 1 and theta 2 from the 0 and minus 0.5 to determined pole, and here the line is bisector of the angle AOP. Next we can go through the step 4. In step 4, to find the pole and 0 of the lead section, draw a line AP parallel to x-axis. The bisector PC is drawn to bisect the angle APO. Angle CPB and BPC are constructed as shown. Angle CPB is equals to angle BPC is equals to 27 degrees from the graph. In the graph we draw the lines with 27 degrees from the left side. Next we can go through the pole of the lead section. PC2 is equals to minus 10 and 0 of the lead section ZC2 is equals to minus 2.65. ZC2 is equals to minus 1 by T2, where T2 is equals to 1 by 2.65 is equals to 0.377. PC2 is equals to minus 1 by alpha T2, where alpha T2 is equals to 1 by 10. Alpha is equals to 1 by 10 into 0.377. Calculating this we can get 0.265. Next we can go through step 5. Transfer function of lead compensator. Transfer function of lead section G2 of S is equals to S plus 1 by T2 by S plus 1 by alpha T2. Substituting the above values in step 4, we can get S plus 2.65 by S plus 10. Next we can go through the step 6 to find the gain K. G of G02 of S is equals to G2 of S into G of S, S plus 2.65 by 10. into k by s into s plus 0.5. Calculating these, we can get k is equals to 42.8. Step 7. To find velocity error constant of lead compensated system, kv2 is equals to limit s tends to 0, s into g02 of s is equals to limit s tends to 0, s into 42.8 into s plus 2.65 by s into s plus 0.5 into s plus 10. By substituting all these values and calculating the values, we can get the 22.684. Next, we can go through the step 8. To find the parameter beta, kvd is equals to desired velocity error constant. A is equals to the factor by which kv is increased. A is equals to kvd by kv2 is equals to 3.5267, such that beta greater than a. Let beta is equals to 4. Next step 9. To find the transfer function of lag section, 0 of the lag section, zc1 is equals to 0.1 into second pole of g of s is equals to 0.1 into minus 0.5. Then we can get minus 0.05. zc1 is equals to minus 1 by t1. Then t1 is equals to 1 by 0.05 is equals to 20. Pole of lag section pc1 is equals to minus 1 by beta t1 is equals to minus 1 by 4 into 20 is equals to minus 0.0125. Next, we can go through transfer function of lag section. g1 of s is equals to s plus 1 by t1 by s plus 1 by beta t2. Substituting the values t1 and beta t2, we can get s plus 0.05 by s plus 0.0125. Step 10. Transfer function of compensated system, gc of s is equals to g1 of s into g2 of s. Substituting g1 of s and g2 of s values in the transfer function, we can get these values. Next, we can go through the open loop transfer function of compensated system. g0 of s is equals to 42.8 into s plus 0.05 into s plus 2.65 by s into s plus 0.0125 into s plus 0.5 into s plus 10. Next, step 11. Check the velocity error constant of the compensated system. kvc is equals to limit s tends to 0, s into g0 of s is equals to 90.7. Hence, kvc of compensated system satisfies the error requirement. Thank you, sir.